Hi, in this video we will discuss how to find the limits of several functions. Let's start with this example. We are trying to find the limit of the rational function here. We have to use either, there are several, you're finding the limit at a number first of all. We are trying to find the limit of this function as x approaches 2. So what are the possible options? We can use either direct substitution, factoring out, rationalization, squeeze theorem, L'Hopital's rule, epsilon delta definition, or graph in the table. Now the graph in the table is the last option or the last resort. If nothing works, then we should go there. Because we are trying to find the limit at a number, these are the following options. So let's try one after the other. That's the way I approach usually the problems. Let's try direct substitution here. When you substitute x as 2 here, you get 2 squared plus 2 minus 6 divided by 2 minus 2. That's going to be 6 minus 6 divided by 2 minus 2, and that's going to be 0 by 0, and 0 by 0 is an indeterminate form. It is an indeterminate form. It is not 0 or it is not any other number. It is an indeterminate form. So this tells us that the direct substitution did not work. So the next option is we want to find out if the factoring out works. So let's see if you can factor the numerator. You can see that the numerator can be factored, and once upon factoring you will get this to be x plus 3 times x minus 2, and the denominator is x minus 2. Now you can see that the x minus 2 term gets cancelled out, so you get limit x going to 2. Upon simplification you get this to be x plus 3. So upon direct substitution you get this to be 2 plus 3 equals 5. So the limit of this function is 5 at 2. However, please remember that if you want to find the domain of this function, this is a rational function, so you want to make sure that the denominator is not equal to 0. So that means x minus 2 is not equal to 0, so which means x is not equal to 2. So that means the domain of this function is negative infinity to 2 union 2 to infinity. So that means 2 is not inside the domain of this function. However, you can really find the limit of this function, and the limit of this function is 5. So that's why we represent limits by open circles, and limit is actually defined on the deleted neighborhood. That means you can exclude 2. In and around 2 you can define the limit. The 2 need not belong to the domain of the function. Now you can use several technological tools to find the limit. One of them is Wolfram Alpha. I'm sure you must have heard about it somewhere. So how do you find the limit of this function? I mean, you write limit. You write this to be x squared plus x minus 6 divided by x minus 2, and you want to find the limit as x approaches 2, then you will get the answer to be 6. Let's see let's go ahead through some other examples. So this is how you find the limit of this function, and the limit of the function is 5. Let's go ahead and work on a different example. So you want to find the limit of this function. So the options are again direct substitution, factoring out, rationalization, squeeze theorem, L'Hopital's rule, epsilon delta definition, graph and the table. Graph and the table is really the last option. So you want to try direct substitution. You want to substitute 1 here, so you get 1 cubed minus 1 divided by 1 squared minus 1, so that's going to be 0 by 0. So that is an indeterminate form. Once again it is an indeterminate form. So what really happened is that direct substitution did not work out. So let's try factoring. I mean, can you factor the top and can you factor the bottom? Answer is yes, you can factor the top and the bottom. When you factor the top, you are going to get this to be x minus 1 times x squared plus x plus 1 divided by x plus 1 times x minus 1. So now x minus 1 gets cancelled out. So this will really translate to limit x going to 1. You have x squared plus x plus 1 divided by x plus 1. Now there is nothing to factor on the top again and the bottom. So you try direct substitution now. You get 1 squared plus 1 divided by 1 plus 1. So that's going to be 3/2. So this is your final answer. So once again, if you want to find the domain of the function, you want to make sure that this is a rational function. So you want to make sure that the denominator is not equal to 0. So you want to make sure that x squared minus 1 is not equal to 0. So you want to make sure that x plus 1 times x minus 1 is not equal to 0. So which means you want to make sure that x is not equal to 1 and negative 1. So even though 1 and negative 1 does not belong to this function, you will still be able to find the limit at 1. And you can evaluate the limit even, you can check the answer for this even using Wolfram alpha. Let's go ahead and evaluate limit of a different function. So here you see that you want to find the limit of this function. So what are your options? You can evaluate using direct substitution, factoring out, rationalization, squeeze theorem, L'Hopital's rule, epsilon delta definition. Then you have a graph in the table. So graph in the table is really the last resort. Now you can try direct substitution, will not work in this problem. Why? 9 minus 9 divided by 3 minus square root 9. So that's going to be 0 by 0 form, and 0 by 0 is an indeterminate form. So direct substitution doesn't work. Now, does the factoring work? No, because there is nothing to factor on the top, there is nothing to factor at the bottom, so the factoring out doesn't work. So now the question is, does rationalization work? Yes, because 90% of the time this is if you see a radical, rationalization would work. Let's try that process. So you want to say limit x going to 9. You want to multiply the top and the bottom with the conjugate, and the conjugate of the denominator is really 3 plus square root x. So one of the tips is don't multiply out the numerator, just keep them the same. So limit x going to 9, you get 9 minus x times 3 plus square root x. Now when you multiply the denominator, you would get this to be what, 9 minus x. So you see you're using the difference of squares formula, you're using foiling it out. When you use difference of squares formula, you get 3 squared minus square root of x squared. So that's going to be 9 minus x. So when you use 9 minus x, that's what is the denominator. You will see that the 9 minus x term gets cancelled out. So this will really lead you to limit x going to 9, and you have 3 plus square root x. So that is going to give you 3 plus square root of 9 upon direct substitution. We are using direct substitution now here. So that's going to be 3 plus 3, which is going to be 6. Hence the limit of this function is 6. Now let's go ahead and evaluate the domain of this function. So you want to make sure that domain means this is a rational function, in fact radical again. Denominator is not equal to 0. So you want to make sure that there is a radical as well. So you want to make sure that x is bigger than or equal to 0. And you want to make sure that 3 minus square root of x is not equal to 0. So you get square root of x is not equal to 3. So upon squaring both sides, you want to make sure that x squared is not equal to, x is not equal to 9. So the domain of this function is really 0 to 9. Union 9 to infinity. So even though the domain 9 does not fall into the domain of this function, we will still be able to evaluate the limit of this function. Now let's go ahead and work another example in evaluating the limit of the function. So here the function is given as this way, and you want to find the domain of this function. I mean, domain of the function is, this is a rational function, so you want to make sure that, in other words, this is a complex fraction really. So you want to find the LCD of the denominator, and LCD of the denominator is really 4x. So multiply the top with 4x and the bottom with 4x. Okay. So now if you multiply that, you get limit x going to -4. You get 4x times 1 over 4 plus 4x times 1 over x divided by 4x times 4 plus x. So now you can see that 4 and 4 gets cancelled out, x and x gets cancelled out, so you get limit x going to -4. So you get x plus 4 divided by 4x times 4 plus x. So now you can see that 4 plus x and x plus 4 gets cancelled out, so you get limit x going to -4. X plus 4 and 4 plus x get cancelled out, so you get 1 over 4x. So that's going to be 1 over 4 times -4. So that's going to be -1 over 16. So the limit of this function is -1 over 16. So let's go ahead and evaluate the domain of this function. The domain of this function is, you want to make sure that the fraction is well defined, or the function is well defined. So which means you want to make sure that the denominators are not equal to 0, which means you want to make sure that x not equal to 0 and 4 plus x is not equal to 0. So which means x not equal to -4. So the domain of this function is -infinity to -4, union -4 to 0, union 0 to positive infinity. Okay, so even though -4 does not belong to the domain of this function, we will still be able to find the we will still be able to find the domain of this function. Okay, so here again, because we are trying to find a limited number, the options are really direct substitution, factoring out, rationalization, squeeze theorem, epsilon delta definition, L'Hopital's rule, and graph in the table. Graph in table is the last resort. I did not try it, but you can see that the direct substitution doesn't work out. I did not use rationalization. Instead, I tried to simplify the fraction, and I used the factoring out technique to evaluate the limit of this function. Now let's say I want to show you how to find the limit of the function using on Wolfram alpha. Let me show that to you so that it will be very clear. Okay, it's not working out, so let's stop here. So I hope this is clear to you. If you have any questions, please let me know through the comments below.